Good morning, students.
Good morning,
Morning,
ma'am.
ma'am.
Okay, very good morning. So, yesterday we finished our second chapter, Human Eye and the Colorful World. So, today we are moving to our third chapter dealing with electricity. Okay, the next chapter, chapter 12, electricity. Okay, have you heard about electricity? Are you familiar with this term?
Yes, ma'am.
Okay, what do you mean by electricity?
The flow of sound.
The flow of charge. I know that from your smaller classes itself you study a definition for electricity. It's a rate, it's a flow of charge. What do you mean by the electricity means it is the flow of charge. So students, we know that electricity is one of the most convenient or controllable and most important source of energy. And if you look around yourself, you can see each and everything that is run with the help of this electricity, right? Can you imagine a day without electricity in your life? Can you imagine a day without electricity? Is
No,
it
ma'am.
possible? No. It is not possible. Even though for 1 or 2 hours, if the power failures are occurs, we are so much distracted or disturbed. So we can say the electricity is one of the most convenient and controllable or most important source of energy. So in this chapter, we discuss about the importance of electricity, what do you mean by electricity, the definition, and what are the different practical applications of electricity. Okay, so let us start. So as Ashik says, electricity is nothing, it is the flow of charge. From our smaller classes itself, we discussed that electricity is the flow of charge. And students, what type of charge is flowing here? What type of charge is flows?
Positive to negative.
The charge is flowing from positive terminal to negative terminal. Okay. What about the charge? What is the type of charge that is flowing here?
Switch on your videos. Switch on the videos.
All of you please switch on your video.
Mark them absent if they don't give any reason.
Okay. Okay, sir.
Pratyush, Aya, Abid, and Steve.
Hence, Steve, please switch on your video. Hiya. Okay, students. So we know that the atom consisting of different particles. What are the particles present in atom? In chemistry, you may have studied about the particles present in atom. What are they?
Protons.
Yes, it's good. Say louder.
Neutron, protons, and electrons.
Protons, neutrons, and electrons. And what about the charge of proton?
Positive charge.
Positive charge. Neutron?
Negative.
Negative.
No. Then what about the charge of electron?
Negative.
Yes. The charge of electron is negative. What about neutron?
Neutral.
Neutral.
Neutron is chargeless, or we can say it is neutral. Okay. And students, the name electricity, as its name implies, it is the rate of flow of electrons. Actually, the flow of electron constitute the electricity. Okay. That is what is we are call it as electricity. So electricity is nothing. It is the flow of charge or the flow of charge through a unit area per unit time is known as electricity. Now you are studying in 10th standard, so we need to make a little bit difference for the electricity in the definition of electricity. So that is what is we are going to discuss. So electric current, the word as implies electric current, it is the flow of electrons. It is the flow of electrons, or we can say electric current is the rate of flow of charge is known as electric current. Suppose you imagine this is a conductor. What do you mean by conductor then? This is a conductor.
Conducts electricity.
Yes, the substance that conduct electricity are known as conductors. Okay. And if the electrons, suppose the electrons are passing through this, we can say here the electricity. Here if the electrons are passing through these conductors, we can say that here the electricity flow is occurs, right? Here the electricity flow is occurs through this conductor, right? And here the electrons are flow through a particular area. This is a conductor. So here the electrons are flows through a particular area and it takes its own time to flow through this conductor, right? Here the electrons are flowing through a particular area and it takes its own time to flow through this conductor. So what do you mean by electricity? Electricity is the flow of charge through a particular area in unit time. Okay, what is electricity? It is the flow of charge. Here charge means electron. Here the flow of electrons flows through a particular area in unit time is known as electricity. Or in much simpler terms we can say it is the rate of flow of charge. It is the rate of flow of charge. What do you mean by electricity? Electricity is nothing. It is the rate of flow of charge. So that is what is known as electricity, or we can call it as electric current. So electric current is the rate of flow of charge. Electric current is the rate of flow of charge. It is the amount of charge that flows through a particular area in unit time is known as electricity or electric current. Or in more simpler terms we can say electric current is the rate of flow of charge. And from this definition itself we can form an equation, a mathematical equation for calculating this current. Okay, so Adidev, can you say what you mean by electric current?
The rate of flow of the
Yes, it is the rate of flow of what?
electrons.
Electrons, or rate of flow of charge, or it is the rate of flow of electrons. So from this definition itself you can form an equation for calculating this current. It is the rate of flow of charge, or it is the amount of charge that flowing through a particular area in unit time. So we can calculate the current or electricity using the equation charge divided by time. Charge divided by time. It is the amount of charge flowing through a particular area per unit time. So we can say current is equal to charge divided by time. Current is equal to charge. It is the amount of charge flowing through a particular area in unit time. Or in simpler terms you can say it is the rate of flow of charge. By this term rate we indicate the time itself. Okay, it is the time taken by the charge to flow through a conductor. That is what is known as current or the electricity. And here this charge can be represented by letter Q. Q is used to represent the term charge. Then can you say how we can represent the term time?
T.
T. Very good, very good. T is used to represent the time. What about current? The current or the electricity is represented by the letter I. So the mathematical representation for electric current is I is equal to Q by T, where I is the current, Q is the charge and T is the time. The mathematical representation for current I is equal to Q by T, where I is the current, Q is the charge and T is the time. Now we can see what about the unit of this current. So I hope that the definition is clear, right? Once again we can recall this definition. Rose, what is the definition of electric current? What is the definition of?
Electric current
It's not clear.
Electric current is the rate of flow of charge.
Very good. It is the rate of flow of charge. Hadidi, what is the mathematical equation for calculating this electric current?
I is equal to
Unmute and say. I is equal.
equal to Q by T.
Okay, what is Q represents? Q?
Charge.
Charge. Q is the charge and T?
Time.
What about I?
Current.
Current. Okay, very good. Now let us see what about the unit of this electric current. So we know that this charge is represented in terms of Q. Students, do you know what is the SI unit of charge?
Ampere.
SI unit of charge, not the current.
Coulomb.
Coulomb. Very good. Coulomb. The SI unit of charge is Coulomb. What about the SI unit of time? SI unit of time? Second. Very good. So here the SI unit of charge is Coulomb, SI unit of time is second. So the dimensional unit, not the SI unit, all of you please listen here. The dimensional unit of current is Coulomb per second. The dimensional unit of current is Coulomb per second. Okay. Instead of writing this Coulomb, you can write capital C per S. Coulomb per second. This is the dimensional unit of current. The dimensional unit of current is Coulomb per second. But the SI unit, the standard unit of time is ampere. Ampere. It is named after the French physicist André Marie Ampere. This is the SI unit of current.
Ma'am, will you say what is the dimensional unit of?
Okay. The dimensional unit of current is Coulomb per second. How we obtained is from the equation we can calculate an unit for this current. The charge is represented in terms of Coulomb and the SI unit of time is second. So Coulomb divided by second, that is Coulomb per second is the dimensional unit. It is the dimensional unit of current. The dimensional unit of current is Coulomb per second. I is equal to Q by T is the equation for calculating the electric current. So from this equation, we can make a dimensional unit for current. The dimensional unit is Coulomb per second. And what about the SI unit? Rizwan, what is the SI unit of current? SI unit of current. Yes, I think some audio problems are there, right? Vishnupriya, what is the SI unit of current?
Ampere.
Ampere. It is named after a French physicist, André Marie Ampere. Okay. The SI unit of current is because he made lots of contributions in electromagnetism. So in order to honor him, the SI unit of electric current is Ampere. It is named after the French physicist André Marie Ampere. So here we discuss the definition of electric current. It is the rate of flow of charge is known as electric current. And mathematically we can calculate it with the help of an equation. I is equal to Q by T, where Q is the charge, T is the time. And the dimensional unit of electric current is Coulomb per second. But the SI unit of current is Ampere. It is named after the French physicist André Marie Ampere. He made a lot of contributions to the field of electromagnetism. So in order to honor him, we gave the name Ampere as an SI unit of electric current, and it is represented by capital letter A. The SI unit of current Ampere is represented by the capital letter A. In addition with this Ampere, because this Ampere is a large unit, we have some smaller units for the current. We have some smaller units for current. The smaller units of current are expressed in terms of milliampere and microampere. Okay. The smaller units of current are expressed in terms of milliampere and microampere. Since the ampere is a large unit, we can express the current in terms of its smaller units. The smaller units of current are milliampere and microampere. And here you can see the relation between milliampere and microampere with that of ampere. You just study this relation because it will be helpful for your numerical calculation. This is milli. 1 milliampere is equal to 10 raised to minus 3 ampere. 1 milliampere is equal to 10 raised to minus 3 ampere. And here we pronounce it as micro. This is the symbol of micro. And 1 microampere is equal to 10 raised to minus 6 ampere. 1 milliampere is equal to 10 raised to minus 3 ampere, and 1 microampere is equal to 10 raised to minus 6 ampere. Yes?
Is this milliampere used in phone batteries?
Sometimes if you want to calculate some quantities, we need to convert it into ampere, because we know that ampere is the standard unit of current. Sometimes some quantities are expressed in terms of milliampere. For example, if a current flowing through a conductor is 10 milliampere, then we want to convert it into ampere by multiplying it with the 10 into 10 raised to minus 3. That is equal to 10 into 10 raised to minus 3 amperes. So, while doing the mathematical calculation, these conversions are important. Clear? Okay. Can we move to the next? Okay.
Yes, ma'am.
Now, we can measure this current that flowing through a conductor with the help of a device. That device is known as ammeter. What is this device? Ammeter. How it is pronounced? Ammeter. Okay. So, ammeter is a device that is used for measuring the current, measuring the value of current that flowing through a conductor. Ammeter is a device that used to measure the value of current that flowing through a conductor. Ammeter is a device that used for measure the value of electric current in a conductor or in a circuit. Yes? Ask it louder, it's not clear. Ammeter is a device that is used to measure the value of current in a circuit. So this is the exact image of ammeter. The ammeter is consist of two terminals. One is black in color and one is red in color. And this black color terminal is represents the negative terminal of the ammeter. You can see these devices in our physics lab. Okay. Negative terminal. Then what about this red terminal indicates? Red?
Positive terminal.
Yes, it is the positive terminal of the ammeter. So, ammeter is a device that used to measure the value of current. It consists of two terminals. One is positive terminal and it is red in color, and another is negative terminal, that is black in color. Okay.
Can you show the last slide?
Okay, of course. Ammeter is a device that used to measure the electric current in a circuit. And it is expressed in terms of amperes, because ampere is the SI unit of current. Most of them have a confusion dealing with this term ampere and ammeter. Ampere is the SI unit of current and ammeter is a device that used to measure the current. Okay. Ammeter is a device that used to measure the current. And you can add one more point along with that. Ammeter is always connected. Ammeter is always connected. Ammeter is always connected in series with that of a circuit. You may be study about the series and parallel connection later. So you just write the ammeter is always connected in series with that of a circuit. Ammeter is always connected in series with that of a circuit. Yes, Ashik?
Ceramic is ceramic.
Is it is ammeter?
I think so.
Ammeter is no. Ammeter is a device that is used to measure the value of current, and it is always connected in series with that of a circuit. Melvin, what is the SI unit of current?
Ampere.
Very good. And how it can be represented? Using which letter?
Capital letter A.
Very good, very good. Anyway, I am happy you are following the class. Okay. Rose, can you name the device that is used to measure the value of current? Ammeter. Good. Then Anne Mary, what are the smaller units of current?
Milliampere and microampere.
Milliampere and microampere. And what do you mean by milliampere? 1 milliampere conversion. 1 milliampere is equal to? What? 10 raised to minus 3 ampere. Badra, what about 1 microampere?
10 raised to negative 6 ampere.
10 raised to negative 6 ampere. Good. Okay. So now we can discuss about the electric circuit. Okay. So electricity is nothing. It is the rate of flow of charge is known as electricity or electric current. Okay. So now I want to ask some questions. Students, you just imagine that we have a well-equipped vehicle with a sufficient amount of petrol or diesel like that. Then what all the other things are needed for a smooth travel or smooth journey? We have a vehicle with a sufficient amount of petrol and diesel. So my next question, what all the other things are needed for a smooth journey?
Oil, engine oil,
Yes, Aditya?
engine oil,
Okay, okay. The vehicle is okay, perfectly okay. What all the other things are needed?
Key to start.
Yes, Melvin?
Smooth road.
Yes, very good. A smooth road is needed. Yes, the road without gutters and all, then only we can travel very smoothly. Right? So just like that, in the case of electricity, we know that electricity is nothing. It is the rate of flow of charge. The rate of flow of charge is known as electricity. So in order to flow the charge, so in order to the smooth flow of charges occurs, if and only if it has a good road, a good path. So the charge requires a good path for its smooth travel. So when in your exam paper, don't write like this, the charge needed a tarred road and or not like that. Just similar to that of our traveling, the electric charge requires a continuous and complete path. Okay, so the continuous and complete path needed by the electric charges to flow is known as electric circuit. So it is a continuous, closed and complete path through which the charge can flow is known as electric circuit. So now we can study a definition for electric circuit. So what do you mean by electric circuit? It is a continuous, closed and complete path through which the electric charges can flow. It's a complete, continuous and closed path. So these conditions must be satisfied, then only the electrons or the charge can easily flow through the circuit. So it should be a complete, continuous and closed path. The circuit is complete, continuous and closed path through which the electric charges flow is known as electric circuit. A circuit is a complete, continuous and closed path through which the electric charges flow is known as electric circuit. So here you can see the image of an electric circuit. Gap between the circuit in the path of the charge flow. Is there any gap here? Here there is no gap. Here it is a continuous closed path through which our charges are flow. That is why the bulb glow here. So electric circuit is nothing. It is a continuous, complete and closed path through which the electric charges can flow is called electric circuit. Is it clear?
Yes, ma'am.
Okay. Now we have two types of electric circuit. One is open circuit and other is closed circuit. We have two types of circuit. One is closed circuit and other is the open circuit. Then can you make a guess what you mean by closed circuit? What do you mean by closed circuit?
Continuous circuit.
Yes, it is a continuous and closed path. That is, there is no gap in between them. Such type of circuits are known as closed circuit. Then what do you mean by open circuit?
It's not closed.
Yes, very good. If there is any gap between the path of the charges, then we can call it as open circuit. So here you have the definition for open and closed circuit. So an open circuit does not have a complete path. So what happens? No electric current flows. Here no electric current is flows. Here there is a gap in the circuit. So what happens? The electrons cannot jump from here to here. So it breaks its journey here. So that is why we call it as open circuit. Open circuit does not have a complete path. So no current flows through the circuit. Such circuits are known as open circuit. And what about closed circuit? In a closed circuit, we have a complete path that allowing the current to flow. Here the circuit is closed. The charges are flowing from positive terminal to the negative terminal without any flow because here the path is closed. So what happens? Our bulb will glow. It produces light. So the current flows only in a closed path or closed circuit, not in an open circuit. Yes? It's not clear? No, you don't need to copy down the diagram. Only write the definition for open circuit and closed circuit. All these are some introductory terms for this chapter, electricity. Okay. You only, yes?
Then how wireless electric appliances work?
Anyone please make it clear to me? It's not clear, that's why.
And then how electrical wireless appliances work?
Why we are using?
He's asking wireless, isn't it?
Wireless arrangements, about the wireless electrical devices, right? Are you asking about the wireless electrical devices? There is some electrical connection between both the electrical appliances. Yes, how electric wireless? But there is a connection between, that is why it is due to the another interesting phenomena of electromagnetism. Okay, it is not dealing with our electricity, it is dealing with electromagnetism. It is one of the practical application of electricity that you have already that you must be studied in our next chapter, magnetic effect of electric current, how these wireless connections are made possible. Okay, so in order to make a smooth current flow, we need a continuous closed path. The continuous closed path through which the charges flow is called electricity. And there are two types of circuits are there. One is open circuit and other is the closed circuit. In the case of open circuit, we do not have a closed path. We do not have a complete and closed path. Such kind of circuits are known as open circuit. In the case of closed circuit, we have a continuous and closed path through which the current flow occurs. Okay, is it clear?
Yes, ma'am.
And in the case of wireless network, some kind of another phenomenon of electromagnetic induction is introduced. We can discuss about in our next chapter, magnetic effect of electric current. Okay. So that's about the electric circuit. And we have two types of electric circuit. One is open and other is closed. In open circuit, we do not have a complete path, so no current is flows through the open circuit. In the case of a closed circuit, we have a complete path that allowing the current to flow. Now we can discuss about the direction of current. What about the direction of the current? We know that in a circuit, this is a representation of an electric circuit. Here it is a continuous and closed path. This represents our bulb. Here, what is this A represents? Can you make a guess what is this A represents? A. A. Not ampere. Ampere is the unit. Ampere is the unit to measure the current. What about A? A device that is used to measure ammeter. Very good. Here in this circuit, this A represents nothing. It is our ammeter. And what about K? K represents key, or you can say it as switch. I think you may be familiar with this term switch. One more term we can use for switch, that is nothing, it is key. Okay, the key or a switch. The key or a switch is a device that used to open or close the circuit. So it is function to open and close the circuit. Okay, so you can see this device key in our physics lab. I will show the image of key in my next class. Okay. And what is this represent? This symbol? Battery. Very good. It is battery. If a symbol only like this, we will study detail about the symbols. Anyway, I am just asking. One is positive and another is negative. What it is called? If you have only one battery,
Cell.
yes, it is known as cell, electric cell. And the combination of more than one cell will be there, then we can call it as battery. If there are more than one cells are there, then we can call it as battery. Okay. If only one battery, normally in our daily life we are used to say it is battery, whether it is one or two, we are used to say it is battery. But if there is only one battery, then we can call it as electric cell. It is known as electric cell. And the combination of more than one cell, we can call it as battery. The combination of more than one cell is called battery. This is bulb, this is ammeter, and this is key. Key is nothing, it is the switch itself. Switch. And this is the battery. And here we are going to discuss about the direction of the current. What about the direction of current? We know that the electrons or the flowing of electrons are responsible for the formation of current. As its name implies, electricity. It is a Greek term coming from electron. Okay, so it is something related to electron. The rate of flow of electron is constitute the electricity or the electric current. What about the charge of electron? Charge of electron?
You-
Yes, it is negative. So the charge of electron is negative and it is flowing from this negative terminal to positive terminal. But the conventional direction of the current, is just opposite to that of the flow of electron. The conventional direction of the current is from positive to negative. What is the conventional direction of the current? It is flowing from positive terminal to negative terminal of the battery. This is the conventional direction of the current. The conventional direction of the current is just opposite to that of the flow of electron. We know that electrons are negatively charged particles and they are used to flow from negative terminal to positive terminal. But the direction of the current is taken as from just opposite to that of the direction of the electron, that is from positive to negative. This is the conventional direction of the current. So the next topic, direction of current. Direction of current. The electron flow is from negative terminal to positive terminal, but the direction of the conventional current is just opposite to that of the direction of flow of electron, that is from positive to negative terminal. The conventional direction of the current is from positive to negative terminal. Is it clear? So here we discuss the definition of electric current, the equation for calculating the electric current, SI unit and dimensional unit for electric current. What about electric circuit? We have two types of electric circuit, open circuit and closed circuit. And now we discuss about the direction of the current. The conventional direction of the current is from positive terminal to the negative terminal in a circuit. That is just opposite to that of the electron flow. The electron flow is from negative to positive terminal, but the conventional direction of the current is from positive to negative terminal. Is it clear?
Yes, ma'am.
Okay. Now, one more term I want to discuss here. What is the equation for calculating the current? I is equal to
Q by T.
Q by T, right? I is equal to Q by T. That is, I is the current, Q is the charge and T is the time. And what is the SI unit of current? SI unit? Ampere. Current, the SI unit of current is ampere. SI unit of charge is? What is the SI unit of charge? Coulomb. Okay, Arjun, what is the SI unit of time? He feeling very sleepy. What is the SI unit of time? Second. Okay. So my next question, define 1 ampere. What is 1 ampere? 1 ampere current is the 1 coulomb charge flowing in 1 second. Okay. It is the 1 coulomb charge flowing in 1 second is known as 1 ampere. So define 1 ampere. What is 1 ampere? It is the 1 coulomb charge flowing in 1 second. Then what about 2 ampere? Can you define 2 ampere?
Charge flowing in
Yes, it is the 2 coulomb charge that flows in 2 seconds. So similarly here we can write, you can expect this question for your exam, define 1 ampere. It's a short answer question. Always ask 1 ampere is equal to 1 coulomb divided by 1 second. It is the 1 coulomb charge flowing in 1 second is known as 1 ampere. 1 coulomb charge flows in 1 second is known as 1 ampere. Okay. And we know that Q is represents the charge and its unit is coulomb. And the charge of electron is 1.6 into 10 raised to minus 19. 1.6 into 10 raised to minus 19 coulomb. This is the charge of electron because the electricity is formed as a result of rate of flow of electron. And the charge of the electron is equal to 1.6 into 10 raised to minus 19 coulomb. Here the electricity is formed as a result of the rate of flow of charge, and by this term charge we are nothing, it is the rate of flow of electron. And the charge of one electron is 1.6 into 10 raised to minus 19 coulomb. 1.6 into 10 raised to minus 19 coulomb. Charge of electron is equal to 1.6 into 10 raised to minus 19 coulomb. And there were a relation in connecting with this charge of electron and that of the charge. Write the next subheading, relation between, these all are some extra informations for you before doing the numerical. Relation between charge of electron and the number of electron. The relation between the charge of electron and number of electron. The relation between charge of electron and number of electron. Q is equal to Ne. Q is equal to Ne. The relation between charge of electron and the number of electron. Q is equal to Ne, where Q is the charge, N is the number of electron, and what is E represents? E represents the charge of electron. E represents charge of electron. So here the Q represents the general charge, N is the number of electron, E is the charge of electron. I will explain this equation with the help of a problem in the next class. You just study this relation between charge of electron and the number of electron. Q is equal to Ne. Okay, so that's all for today. Can I rub this?
Yes, ma'am.
Okay. So this is the relation between charge of electron and number of electron. Q is equal to Ne. And actually this is known as condensation of charge. This is only helpful for your higher studies, not in this class. You just understand this term, Q is equal to Ne. So let me take your attendance. Anjita.
Ma'am.
Okay. Hadi is here. Melvin present. Prajot present. Afsana. John present. Adil present. Emil present. Surya Krishnadas. Surya. Okay. Ashik present. Arjun present. Hadidi is here. Aditya Krishna. Nas. Savio. Haya. Okay. Muhammad Aman. Okay, Afsana. Muhammad Aman. Absent. Present. Okay. Vishnupriya is here. Meghna. Muhammad Aman absent. Okay. Sainaba. Meghna present. Sainaba.
Present, ma'am.
Okay. Rifa present. Vishnu VB is here. And Mary, Badra, Nisia. Adidev present. Riswan is here. Nirubama, Rosabi, Fia. Lolita. Aman Shakir. Aman. Okay, here. Pratyush, Hain Steve, Jahan, Aditya, Amina Naurin. Amina Naurin. Okay. Thank you, children. We can meet in the next class. Okay. With this, we can wind up. Thank you all.
ma'am.
Have a nice day.